Okay, so I want to continue our discussion on the UI management inside of Unit 4. And really, we've been doing a big deep dive into graphics user interface programming, which is really event driven. And so the graphic user interface framework that we've really been examining has been the JavaFX framework. It's the most modern and up-to-date windowing or graphics-based user interface available to us in Java. It's still actively being developed, in fact, and constantly rolling out with new updates as the JDK, as Java continually updates. And so we spent a lot of time, a lot of our previous lectures already kind of building up the core components that define JavaFX that allows us to create a basic graphic-based application. And we looked a lot about the controls that are available to us. And we kind of just assumed how to set up the event handlers, how we can go ahead and do things in response to the user interacting with the windowed system, with the graphic user interface system. So I would definitely like to take the opportunity to actually have a dedicated lecture to talk about event handling and event-driven programming, since that kind of practice is what drives any kind of graphics-based application. So a quick overview on this presentation is that we'll do an introduction to event handling and event-driven programming. We'll ask what is an event and answer that. We'll look at the hierarchy of the event class in Java. We'll look at the different types of the basic types of events. So here, I'll put this as the basic types of events. We'll go ahead and look at events in JavaFX in particular. Then we'll look at event handling. Then we'll talk about the phases of event handling and event filtering. Then we'll talk about the difference between event handling versus event filtering. We'll talk about the difference between anonymous classes versus Lambda expressions. We've mentioned before, but we'll just articulate it inside this video. We'll talk about how to add and remove event filters or event handlers inside of our application, inside of our JavaFX app. We'll talk about convenience methods, and then we'll talk very specifically about the event types that exist. Here, we can do this specific event types. Okay. So in JavaFX, we can develop GUI applications, web applications, graphical applications. And in all of these applications, all these windowed applications, whenever the user interacts with our application, which we're going to model as nodes, effectively in a tree. So a tree is just a special type of graph that has a root node, and then from the root node, you build out the rest of your graph. So that root node has children nodes, and those children nodes have children nodes. And effectively, any kind of XML document, any type of HTML document, any kind of our GUI windowed application can effectively be modeled as a graph, which if you haven't formally learned about graphs, you'll learn much more in discrete mathematics and, of course, data structures. Anyway, so in such applications, whenever a user interacts with the application, an event is said to have occurred. So, for example, when we click on a button or move the mouse or enter a character on our keyboard or select an item from the list or scroll the page, these are all activities that cause an event to occur inside of our application. And so in this lecture, we'll explore more this concept of event-driven programming, which we've already seen in practice. So what is an event? Well, an event is any change of state in an input device, such as a mouse or a touchscreen, or a user action, such as an action event, or a background task. Events can also be fired as a result of, say, for instance, a scroll or edit events on complex nodes, such as table view and list view. So at a very basic level, the event object is a class with a surprisingly small number of parameters. It doesn't hold any executable code, nor does it run any code. It's just a flag to the system that something has changed. So JavaFX then provides significant support to run executable code defined separately through the event handler class on any changes of state. So there are a total of 90 separate types of events supported by JavaFX, with the capability to extend the event class and define additional custom functionalities. So if we want to look at the event hierarchy, actually in java.util in core Java, there is an event object. And so the JavaFX event class extends this event object that's inside of the standard library, the core library of Java. And then from this event class, all the other events, action events and input events and window events, and there's 15 other ones that go down, all inherit off of this event class. And then each one of these themselves can go ahead and have much more specific concrete classes, such as drag events or context menu events or gesture events or key events or mouse events, that then define every possible state change that could occur that you can listen for, and then bind some kind of handler, some kind of callback function to trigger in response to that event occurring. Okay, so let's talk about the basic types of events here. Okay, so the events can be broadly classified into the following two categories. You have foreground events, and those are those events. And so maybe I'll do this. Categories of events. Oops, not quite right. Jesus. This is okay, but there we go. Categories of events. Okay, so you have your foreground events, and those are the events which require the direct interaction of a user. They are generated as consequences of a person interacting with the graphical components in a GUI. So an example of foreground events are like when you click on a button or move the mouse or enter a character from your keyboard or select an item from a list or scroll the page, right? It's things where the user is actively engaging. But there's other types of events too. You have like these background events, and those are the events that don't require an interaction from the end user. And examples of that might be like the operating system interruptions, or if there's some kind of hardware or software failure, or if there's like a timer that expires in the background that you want to trigger a action to, or if there's something loads into memory, like for instance, if you have a view that loads. So these are all instances that it is based off of some criteria internal to the system that's not triggered by the user, but something else in the system itself. So the events in JavaFX provide support to handle many types of different events. There's the abstract class named event that we talked about before. And so that's inside the package of the event package, which its root package is JavaFX. And so that's the base class for all events. And so then we would use the subclasses that then extend and instantiate the event. So the types of events we really concern ourselves about are mouse events. And so this is an event, an input event that occurs when the mouse is clicked. It is represented by the class named mouse event, and it includes actions like mouse clicked, mouse pressed, mouse released, mouse moved, mouse entered target, mouse exited target. There's a ton of them. You have the key event, and so that's an input event that indicates that a keystroke occurred on a node, and it's represented by the class name key event. And so that includes actions like key press, key release, and key typed. We have drag events. And so this is an input event which occurs when the mouse is dragged. It's represented by the class name drag event, and it includes actions like drag entered, drag dropped, drag entered target, drag exited target, drag over. And there's more than that as well. And finally, the ones that we're really going to take and examine would be the window events. And so this is an event related to the window showing hiding actions. And if we saw some of these already when we first introduced JavaFX, and it's represented by the class named window event. It includes actions like window hiding, window shown, window hidden, and window showing. So in terms of event handling is the mechanism that controls the event and decides what should happen. So if an event occurs, the mechanism has the code, which is known as an event handler, that is then executed when that event does occur. So JavaFX provides two different ways to respond to an event. We have what's called a handler and a filter. Either way, they're both kind of classified as event handlers, but they trigger at different times. We're going to talk about it in just a moment. So in JavaFX, every event has the following fields. So it has a target. So the target inside of an event instance is the node on which the event occurred. A target can be a window, it can be a scene, it can be a node. Every event will have a source. This is the source from which the event is generated. For instance, with a click, the mouse is the source of the event. So if you click on the mouse, then it's telling you, oh, this is the thing that created the event. Every event has a type, and so the type is the type of the occurred event. So again, in the case of the mouse event, it could be mouse pressed or mouse released, or the types of events that might have been defined when we get that click. And then finally, every event has a consumed attribute that's a Boolean attribute. And so what it models, though, is at any point in the process, including before an event has actually reached its target, the event can be consumed, and then that process immediately stops. So again, we'll talk a little bit about what that concept of consume means once we start talking about what the flow of, what the phases of event handling are. So assume that we have an application where we have this circle, we have a stop button, we have a play button that are all inserted into a group of objects, so that are then put into a scene and then put onto our stage and then rendered into this windowed application. So if you click on the play button, then here, if I click there, then the source field of that event that's going to get generated will be the mouse. And the target of the event is going to be the node that represents the play button. So it's going to be my play button. And then the type of the event is going to be a mouse click, and consumed is going to be false unless we manually toggle it to true. Okay, let's talk about the phases of event handling. So whenever an event is generated, JavaFX undergoes the following phases. It's going to do target selection, and then it's going to do route construction, and then it's going to do event capturing, then it's going to do event bubbling, and finally, it's going to call on the event handlers or event filters that are defined on there. Okay, so let's talk about target selection. So here, again, in the prior example that we had, we said, what if we click the play button? So that's our target selection. The source node that generated the event is going to be selected. And say, for instance, our scene contained that group with a button in it. If you click the button, then the button becomes the event target. So once we have the target selection, we move to the next phase, which is going to be a route construction. So whenever an event is generated, the default initial route of the event is determined by construction of what's called an event dispatch chain. And so it is the path from the stage, right? So the stage is the actual window all the way to the source node. So in this instance, our stage goes to scene, our scene goes to group, and our group goes to the play button. Then what we do is the event capturing phase. So after the construction, the event dispatch change, the root node of the application dispatches the event. So the stage is the one that dispatches the event, and it dispatches it to its children, and then to its children all the way until we get to our target. So the event travels to all the nodes in the dispatch chains from top to bottom. If any of these nodes has a event filter function or method registered for the generated event, then it's executed at this time. So know that event filters are executed during the event capturing phase. So if none of the nodes in the dispatch chain has a filter registered for this event, then it's passed to the target node, and finally the target node processes that event. So this is where the idea of consumed comes into play. And again, I'll mention this a little bit more, but since we start at the root node, and if we registered an event filter on, say, for instance, scene, then we'll use the event filter function here, and then we can consume the event before it populates, before it goes down any further down my tree. And so then we can stop it from going to its target even. We can consume it before it even hits its target, hence the name event filter. Again, we'll mention that a little bit more detail in another slide. Then the next phase is what's called the event bubbling phase. And here, at this point, there was no event filters that consumed the event. So the event did get to the target that was interacted with, that generated the event. And so here, if there is an event handler on that node, on the target node, then it's going to trigger that, but then it's going to populate. It's going to go back up from the target to its parent, to its parent, to its parent, all the way until you get back to the root, until you get to the stage, and trigger whatever event handlers might be on any one of those nodes as well. So we can actually trigger multiple event handlers with the one event that gets generated. And then finally, when we get to the stage, that process is complete. So just some words I want to state after that is just talking a little bit about the event handlers and the event filters. Event filters and handlers are those which contain our application logic that processes the response to an event, that processes on top of an event. So here, I'm just trying to highlight that each one of these nodes can have its own event handler or event filter attached to it. So a node can register to more than one handler or filter, right? So a node can actually have multiple callback functions for all sorts of events. So it might respond to a key event. It might respond to a click event or a drag event. And so in the case of parent-child nodes, you can provide a common filter or handler to parents, which is processed as the default for all the children nodes. So for instance, if I wanted all of these to have a similar behavior, I could just create an event handler that listens on group and then gives me the consistent behavior if I click on any one of these children, for instance. And then as mentioned earlier, during the event processing, is when the filter is executed, and it's during event bubbling when the handler is executed. And so all the handlers and filters implement the interface event handler of the package JavaFX.event. So it's all in the event package, and whether it happens during the capture or bubbling phase, it's still called an event handler. We just discriminate whether it's called an event filter because it can block it before it gets to the target versus event handler, which means it hit the target and then it's going to start, and then it does it in response. It handles the event. And here, yeah, this is just the slide I was mentioning that goes a little bit more into detail, just repeats what we just covered. We're just highlighting the fact that filters are triggered here during the event capturing phase, and the handlers are triggered here during the event bubbling phase. So that's going to be our distinction between filters and handlers. But other than that, they're exactly what we've kind of seen in our prior examples. And so the difference isn't only just when these handlers get activated, but it's also that the filters can prevent the child nodes from receiving the event. Hence the term calling them filters. It could filter the event before it ever gets to its target. And I just want to have a couple of slides that kind of highlight the distinction between using an anonymous class versus a Lambda expression to define our event handler. So keep in mind, an event handler is typically in most languages, including really Java, it's really just a callback function. So it is a behavior. It's designed to be a behavior that processes, that reacts, that does something in response to an event that occurred. And so typically in Java, we don't really have functions. A function is like a free floating method. It's a method that's not attached to a class. Java is extraordinarily object oriented. So there wasn't a mechanism really just to make a function in and of itself. But what you could do is create an anonymous class that has a particular function that the JVM will try to execute when that event occurs. If you register an event handler with the JVM. And so if that's the instance, then you'd have to have this handle method. So the event handler object is an object with a single method, which we need to override when we instantiate it. As the event handler interface is parameterized, it passes in an event, we have to specify what event type we're handling. So in this case, it would be like a mouse event. And again, we could save that even to a variable. So we can have a data type event handler, and we can use the parameterized typing here. So we're going to say the type of event we're going to handle is going to be a mouse event. We can give this a name, event handler. So that's just a label. And then what we'll do is we're going to create a new event handler called the constructor. This constructor doesn't exist yet, but what we can always do is define a block of code that's going to go ahead and represent this instance. And so what we have to do inside that block of code to create that constructor to become a concrete constructor, we need to override the abstract method inside of it. It has one abstract method. It's this handle method. It has a parameter. So if we want to override it, we have to pass in that parameter. It's going to use whatever the data type is that we specify here. So by default, it's just event, but we can go ahead and get the more specific typing that we'd like to do, right? It's always better to go ahead and use this parameterized typing when possible. So here we can declare it's going to be a mouse event. And then inside here would be our executable code. So again, this is the old way that we used to have to do this. Now, Java, not too long ago, has updated so that we can actually use Lambda expressions whenever we would previously have to use an anonymous class. So if we want to replace the definition with a Lambda, an event handler is a functional interface. And so that's an interface with a single method, hence the type, the concept of what a function is classically defined as. So effectively a method that doesn't belong to any class. So for convenience, the handle method of the event handler interface can then be specified as a Lambda instead. So here we would still call this an event handler, because again, event handler is just an interface. But the handle method, we can assign the functional interface to that interface label here. So event handler of data type mouse event will still have this same labeling, so we can save it into a variable, and then we'll have this assignment operator, and this is my Lambda expression. I can have my event, and then my arrow function, and then my code block that actually is going to define what I'm going to do in response to that event. It's going to contain all my statements. So this is much less verbose. This is the preferred method now, according to Oracle, when doing anything related to event handling. So both of these work, this and this, but this is the method you should be using moving forward. And just to compare them and contrast, you could see that this is much easier to read than this here. Okay, let's talk a little bit more about event filters and handlers. So whenever we set up a event listener or handler, or let's just call them handlers from now on, they listen for event types. So recall that whenever we set up a handler, we have to define what type of event it's going to listen for and then execute in response towards. So we have to add and remove the event handler to the event. And so when we define and add an event handler to a node or task, we define what type of event we want our code to trigger from. And so as an example, if we want our code to trigger from any mouse event on the root node of our scene, we can use an event type of mouse event. And then inside there's a constant value that represents that event type. And we'll look a little bit more, a little deeper into this presentation of all the different event types that exist in like the mouse events and the key events and the drag events and whatnot. So if you want to remove an event handler at a later point in your code, you need to keep a reference of your event handler object. So a lot of the times what we've been seeing previously when we've been playing around is we've been passing our event handler object into into the method that sets our event handler, and we haven't been storing a reference. But if we ever want to remove it, then we have to store a reference so that we can then tell the event dispatcher, hey, remove this event listener whenever these events occur. Okay, let's talk a little bit about adding and removing an event filter. And then we'll talk about how we can add and remove an event handler. So to add an event filter to a node, you need to register the filter using the method add event filter. And that's defined in our node class. Remember, everything inside of our scene is effectively a node because it's all part of the scene graph. So how that might look would be something like this. So suppose we have this event handler instance that we're creating, and here we'll use the anonymous class. So we'll override this handle method, and here we'll do the system.out.println, and we'll take the circle, let's say the circle from the example we saw, and we're going to fill it to be blue. So we're going to pass in the color of dark slate blue. So then if I want this event handler, so here this event handler is now just a event handler object. So up to this point, we've been defining that as the parameter, but we can actually just save that into a variable. And then that makes this code where we add the event filter or the event handler much more readable. So on our circle, and actually, probably want that. So on our circle instance, we're going to add the event filter where the first parameter is the event type. So inside of the mouse event class is a constant that represents the event that is a mouse click. And then the second parameter is going to be that event handler object that we just created here. So in the same way, we can then remove an event filter using the remove event filter method, where we can say, what is the event type that we want to try to remove an event listener or event filter or event handler on. And then we can pass it that same that event handler object that we want to remove from the event dispatcher. Okay, let's look at an example program really quick where we actually go ahead and do this. So suppose that, so the first thing we're going to do in the sample is we're going to go ahead and do our imports. So here we're going to import the launch method from application. We're going to import the application class. We're going to go ahead and import the event handler class. We're going to go ahead or interface. We're going to go ahead and import the mouse event class from input. We're going to go ahead and get a group so that we can go ahead and use that as a layout component. We're going to go ahead and import scene because everything has to be defined in a scene. We're going to import color because we're actually going to play around with colors in here. So we need a color class. We're going to go ahead and draw a circle. So we're going to, from package shape, import the circle class. We're going to go ahead and use some fonts and font weight. So we'll go ahead and grab those text attributes from the text package. We'll also go ahead and import the text class so we can actually build a piece of text to add into our window. And then obviously we're also going to import our stage because that's the window. That's where everything goes into. So we can display everything so it becomes visible. Okay, now let's kind of stub out our class declaration. So up to this point, all the demos I showed you have been kind of throwing all of our code into the start method. I want to show you a little bit better approach on how we can build out a little bit more complete application in this presentation. So here, what we're going to do instead is we're going to build this out the same way we might build out a normal Java application, where instead of putting all of our code into start, we're going to have these helper methods. And just to make this more readable, while we're going through it, I'm going to show you my stubbed out implementation. So I'm going to have this public class event filter example. It's going to extend my application class, right? So that means this is going to be my GUI application, my JavaFX application. Remember, we always need to have a start method. And so our start method right now is empty, but we're gonna talk about what we're gonna put into it in just a moment. It does require a stage to be passed into it. We're also going to put a main method in there. Our main method is going to call the JavaFX launch method. And so that's what's going to be the launch point of our application. Main method always represents our launch point. And then over the course of the next couple of slides, we're going to use these. So we're going to create a method called setup text. It's going to be helper method. Notice these are all helper methods because they're all private, right? They're all going to be called inside of our start method. So this setup text helper method looks like it's going to return back to me a text instance, probably so I can then put it in my scene. This setup circle method is going to return back to me a circle instance. This get mouse handler is going to have a parameter where I can pass it in a circle instance, and it's going to return back to me a event handler object. And then finally, this setup scene method is going to take in a circle and a text instance. So these two things that we can set up here, and it's going to return back a scene instance. So we kind of have an idea, but we don't have any implementations, right? We just have open and close curly braces, but from the get-go, we can kind of know what the smaller work, if we start to deconstruct and kind of decompose our work into various methods, we can see the work that we're going to be implementing over the course of this example. So let's start with the setup text. So with setup text, I'm going to instantiate a new text element. Then I'm going to set the font so that it's bold and it has a weight of 15, but I'm not going to affect the actual font style, so I'll leave that null. I'm going to set the fill color to be crimson. I'm going to set the X position of our text to be 150 and the Y position to be 50 inside of our layout. And then finally, after I build that out, after I set all the attributes, I'm going to return the text. So if I go into my start method and I want to now use this helper method I just created, I can then now say, oh, I'm going to create this new text. And I'm going to get that by invoking my setup text method. And you can see how that starts to clean up the logic of my start method. Okay, the next helper I'm going to do is going to be to set up a circle. Here, I'm going to create a new circle. I'm going to set the center, X position and Y position of the circle. I'm going to set the radius of the circle. So to give me the width of my circle, I'm going to set the fill value of my circle to be brown. I'm going to set the stroke width, so essentially the outline of my circle, to be 20 pixels. And then after I'm done setting all these attributes and customizing my circle, I'm going to go ahead and return that circle. So that means in my start method, instead of having to have this big block of code, I can just go ahead and declare a local variable circle and then assign it the value that returns back from setup circle method. The next thing I want to do is go ahead and create that get mouse handler function, implement that. So here, I want to show that I can actually return back a Lambda expression. That's completely valid. So I can do get mouse handler. I have this circle instance that I'm passing into it. I can return back a Lambda expression, which will be an event handler. Look, that's a valid value for event handler object. So again, my notation here is I require of an event, then I use the arrow function and I bind that to effectively a block of code that's going to say system.out.print hello world, and it's going to take the circle that I passed in here, and it's going to set the fill value on it to be that dark slate blue color. Okay, so what's going to happen in my start method in response to that is I'm going to go ahead and create a local variable of data type event handler that is parameterized as a mouse event. I'm going to give it a label event handler, and I'm going to assign it the value that gets returned back to me from that helper method, get mouse handler. And I'm going to pass it in the circle I created here. Then once I have that event handler, it's not registered with my event delegator yet. And with the JVM, we haven't registered with the inside of JavaFX yet. Now the registration happens on a per node basis. So on my node of my circle, the thing I want to listen to respond to events, right? The thing that I want the target to be for this event, I'm going to say, hey, add a event filter. So this is the event filter demo. We're going to, the first parameter is going to be what's the event type. So we're going to say, hey, on the mouse event, we want to listen for a mouse clicked. And then the second parameter is going to be, oh, we want to bind that event handler function. We want to register the event handler function we got here, which got returned here, for mouse clicked. Okay, the next thing I want to do is define that setup scene method. So again, that takes that circle and that takes that text. I'm going to create a container node. So a group is a type of container node. I'm going to add my circle and text into my container node, into my group. So now I have my group, which is going to be my root node. And then I can set that root node into my scene and then give my scene a width and a height. And then I can even set a fill value, a background fill value on my scene. I'm going to return that scene. So inside my start method, when I create my local variable to create a new scene, I can use that helper method to set up scene using the local variables I've defined in here. And then finally, I'm going to add to my scene a title that just says event filters example. I'm going to then take my, I'm going to take the stage and I'm going to set the title to my stage. That's the window. Then I'm going to take my stage and I'm going to set the scene we just created into my stage. And then I'm going to tell my stage to show. And so when I do that, I should be able to compile and execute my code. And so I should get something just like this, where I can click on the circle and it's going to change that color. And in fact, why don't we test that out? Let's see if it lets me go, if my computer allows me to go to IntelliJ. Okay, so here we go. This was my event filters example. I'm going to open this up and I'm just going to go ahead and run this. So yeah, this is the thing I have. Yep, I have a main method. I can tell it to run from my main method right there. It's going to launch my application. And just waiting for it to build. So every time we go ahead launch JavaFX, it's got to build our application out and then it'll go ahead and launch it. And there we go. We see we have that background fill, we have our text, we have our circle, and we have an event listener. So when we click on the circle, so first I'm going to click not on the circle. See, the target here is the group, right? This is the text. Nope, no. Now, when I go on the make the target the circle, I have an event listener. So when I click on that, you can see, oh, look, it turned that slate blue. And look here, it also put to the console hello world. And then each time I click on that, well, it's already blue, but you can see it now says hello world. And here we also got to see how we can kind of do shapes as well and kind of just draw things into our JavaFX scene. Okay, let's go back and continue on. Okay. Okay, let's talk about adding an event handler to a node. So that was an event filter. So that effectively was triggering that event handler during the event capturing phase. But what's more typical is that you set up an event handler. So that happens during the event bubbling phase. So to add an event handler to a node, you must register the handler using the method add event handler. And in the same way, we can remove an event handler using the method remove event handler. Now, all of this looks exactly the same as what we've done just a moment ago, but instead of, see, we're still creating an event handler object in the same way, right? But we just register it. We're still registering an event here. And actually, we don't have to import it from that scope. We're still registering with two parameters, an event type and a event handler object. We're just using a different method name and just triggers at a different point. Okay, let's look at an example. This time, we're going to handle a couple of different events in this demo code. So I'm going to import the application class. I'm going to import the event handler interface. I'm going to import the key event and mouse event classes so that I can go ahead and access the event types and also parameterize based off of those event types for my event handler. Going to import the stage because that's my window. Going to import the scene because that's everything that actually that contains my stage graph. I'm going to import a group because that's going to contain my collection of elements, my collection of nodes that I want to display and add to the scene. Going to import color because I want to change the color again. I'm going to import a Phong material because I want to start playing around with 3D lighting to kind of highlight how I can do that. So if you're not familiar, Phong material allows us to start using effectively shaders. I'm going to go ahead and get a text fields. That's a control type. We've seen that before. Going to import my text class so I can add text to my scene. I'm going to go ahead and also import the font and font weight so I can kind of modify the attributes of my text. I'm going to go ahead and import from the shape package a box because that's what I'm going to apply both the color and my Phong material on. And since we're now talking about using a Phong material, since we want to talk about starting to render conceptually in a 3D space, I'm going to actually also for my scene import the perspective camera class so that I can actually set up a viewpoint of my camera. And then I also want to do some transforms. I want to mutate that box so that we can make it spin. So that's what's called a transform. So transformations in 3D space are either rotations, they're translations, which are movements, or they're scales, which increases or decreases the size of them. So here we're going to play with rotating a shape inside of our JavaFX application. And since we want to do that rotate transition, we're actually going to also import rotate transition for the animation from the animation package. And then from java.util, we're going to import duration so that we can actually give a timing to our animation between frames. So again, we're building out just slightly more complex applications in this presentation so you can see what a fancier JavaFX application looks like. Okay, so the next thing I want to do is I'm going to create a stubbed out implementation of my class. So here, my class is going to be called public class event handlers example, and that's going to extend my application, the abstract class application in JavaFX. So here, I want to take a different approach than what I did last time, just to show you different ways we can implement our applications, just to give you a different flavor of spice of how we could do this in Java. So we still are going to have the start. We have to override that start method. We're going to initially stub it out. So it means we're going to declare it, but we're not going to assign a set of code in between the curly braces yet. So again, effectively, we're kind of building an interface into our class because we're just defining all the methods it's going to have. I'm going to declare the main method, and actually, I'm going to I'm going to actually concretely define that. I'm just going to launch the JavaFX application. Then I get to define all the helper methods. Now, unlike the other helper methods, notice here in this implementation, again, they're all private because they only need to be viewed from the start method. They're all intended to only be made to make the start method more readable. So each of these, it breaks up the work of the start method. So instead of the start method being like 150 lines of code, it's like 10 lines of code per kind of task. But instead of having return types like the other example I did, all of my return types are void. And the reason why I can do that is this class can be instantiated. In fact, it is instantiated. So it can also have instance variables. So instead of defining inside of my start method all the local variables and passing them across my methods as parameters, I can have blank parameters in my helper functions. I can have no return types, all void, and I can just define all the data that exist as instance data, private instance data that can then be accessed across all of my instance methods. So my instance variables then will be a box, it'll be some text, it'll be this rotate transition object, it'll be this text field, and it'll be this scene. So again, just a different way of doing the same thing, which is defining all the actions we want our start method to be able to go ahead and undergo. Okay, so let's start to implement this out. So the first thing I'm going to do is I'm going to create this setup box. So I'm going to create a new box. I'm going to set the width, the height, and the depth of my box. I'm going to then move the position of the box. So since my box exists in three-dimensional space, that's why it's got a width, a height, and a depth. Then I need to define an XYZ coordinate. And so I would use translate to be able to give it those coordinates. I'm going to create a new instance of that Phong material. And then I'm going to set how light reflects off that Phong material. So we're going to do a diffuse color, and we're going to give it a coloring of dark slate blue. So that'll allow us to apply a color to our three-dimensional box. And then I'm going to, on the box, set the material with that material component we just made, that material object. For setup text, I'm going to go ahead and create a new text element. I'm going to set the font of the text. I'm going to fill the text. I'm going to give that text an XY coordinate. For setup rotation, I'm going to make a new rotate transition instance. And again, I'm essentially tethering this, since I'm not declaring a local variable, I'm assigning this to the instance variable. I'm going to set up a duration. So this is my animation object. So I'm going to set up a duration where it's going to update to the new transition every second. So every 1000 milliseconds. I'm going to take the box instance variable, and I'm going to set that as the node for the thing for the rotate for this animation. So I'm going to register a node to this animation. I'm going to then set the axis of rotation as the y-axis. So on the rotate class, there is a constant that is the y-axis. I'm going to set the angle of rotation to 360. And then the cycle count per frame will be 50. So it's going to rotate in 360 degrees, but for each frame, it's just going to rotate by 50 for each transition. And then we have the ability to set auto reverse value. We're going to just keep that set to false. We're going to, inside of our helper method, we're going to set up a text field. So we're going to create a new text field, and then we're going to set the X and Y position of that. And then we're going to set up a key handler. And so what this is going to do is we're going to create a variable of event handler for a key event, and we're going to bind to that variable a Lambda expression. So it's going to be given some event parameter. We'll use the arrow operator to then bind that, to input that into a block of code. And so we're going to access that instance variable rotate transition, and we're going to call it to play. And then on our text field, that is an instance variable, we will add the event handler, the event type, and then that event handler function we just went ahead and created, that event handler object we just created, pass it as a second parameter. And then we'll set up a mouse handler. So here we'll create a event handler that's parameterized for mouse events, and we'll have a Lambda expression bound to that, which will access the instance variable rotate transition, and it tells it to stop. And then I will bind that to box. So this one was bound to our text field instance variable. So when you press the key, it would play the animation, where when this one, if you click on the box, so on this click event, and again, we don't need all this, but we imported mouse event. So when you click, when the mouse is clicked and it's on the box, then it's going to stop our it'll stop our animation. We'll set up our scene. So here we'll take and create a group, a container, and pass our box, our text fields, and our text elements into that. That'll create a root node. Then we'll add a root node into a new scene and give our scene a width and a height, 600 and 300. And then for setting up our camera, what we'll do is we'll create a new camera object, right? Perspective camera is a class, so we'll create a new perspective camera. We will put it in position. So we got to give it an X, Y, and Z coordinate. So set translate X to 0, set translate Y to 0, set translate Z to 0. Then we'll take this camera instance, and inside of our scene, we will set our camera. So that allows us to use our scene in a 3-dimensional capacity. And so what our start method is going to look like then is just an invocation of our helper functions, our helper methods. So we have a setup box, setup text, setup rotation, setup text field, setup key handler, setup mouse handler, setup scene, setup camera. And none of these are creating local variables, because every action inside of these helper methods were affecting the instance variables that we declared inside of the class scope, inside of the scope of the class, and not in the scope of the any one method. Then we'll set a title to our stage. We'll set the scene into our stage, and then we'll finally show our stage. So again, these start methods look way more readable in this approach. And then what we can do is we can compile and execute our code. And so we should get something that looks like this. And actually, why don't we go ahead and play around with this so that we can actually see in real action what one of these what a 3-dimensional, there we go. Let's go to event handler example here. Let's see what in action, what a 3-dimensional box looks like. So I'm going to go to my main. I'm going to click the green arrow there so that we can go ahead and run that. And so we'll give it a moment for Gradle to build out my project. It takes just a couple of moments. And I feel like JavaFX's windowing system kind of battles with the Zoom share screen for a little bit. As a bolt of lightning that hit. Okay. Here I have a window. Here, my stage and my scene. Press a key to rotate box. So I'm going to press a key, and look, I'm focused in on the text field. So I can press it on the text field, and notice when I put any key, it's going to cause the play on that animation to occur. And so suddenly I have this scene that's going to rotate indefinitely until I click on the box, where I can now tell it to stop. Excellent. And then if I go back in here and press another, it's going to cause it to spin again. And then I can press there and stop. Okay, let's go back to our slides. Okay, just take a couple moments since my computer likes to misbehave a little bit. Okay, let's move on to the next slide. So the next slide I want to look at is using convenience methods for event handling. So what we've seen so far for event handling was to go ahead and add the event handler or remove the event handler. But there's other, and on those instances, we have to define what is the event type and then the callback function. But sometimes there's a faster way to go ahead and set our event handlers using built-in convenience methods, such as set on mouse press to define our event handler. And that way we can just pass in the handler without having that first parameter. So for instance, the general syntax is set on, and then the event type, and then your set of parameters. So here are some examples where you can set on a mouse pressed, or you could set on a key released, or you could set on a task running, or you could set on a scroll finished. So all the different event types, you could just put the word set on in front, and then you don't have to have that first parameter for that event type. So using convenience methods for event handling, convenience methods are useful because you can remove the event handler without having to remove the reference by invoking the same method and passing a null reference. Right. So they are also guaranteed to execute after any other event handlers of the same type on that node, because a node can have multiple event listeners or event handlers for the same event. So you can even use this to define an ordering. So some of the classes in JavaFX define event handler properties. By setting the values to these properties using the respective setter methods, you can register an event handler. So the methods are, again, known as convenience methods. Most of these methods exist in the classes like node and scene and window, and they're available to all their subclasses. So an example of using the set on mouse clicked would look like this. We have some node, let's say it's a play button from our demo. We can call instead set on mouse clicked. And because now we've defined the event type we want to set a event handler on, the only thing we have to pass in to the parameter is an event handler object. And I can either pass a literal event handler object, so I can use this Lambda expression, or I can save it into a variable and pass a reference to the variable, right? Either is fine, and it just depends on you what you prefer in terms of readability. Okay, let's look at an example here of using convenience methods. We're going to do another kind of more complicated application, so you kind of see JavaFX in a more kind of interesting approach than just rendering like nodes, like just a text and pictures and whatnot. So we're going to go ahead and do another animation. So I'm going to grab an animation where we can do a path transition. So we can define a path that we can move our node across in our scene. We're going to, of course, import our application. We need to extend application and actually define the start method. We're going to also import group, because group is just going to be the layout component we're going to use to group our nodes together. We're going to go ahead and import node, which is the parent class of everything. I'm going to use that in one of my functions. So I'll tell you when you're using that. We need to import scene because we need to add a scene to our stage. Going to import a button from the control package because we're going to have a button in here. We're going to play around with color again. So we'll go ahead and import the color class from the paint package. We're going to play around with the shape of circle. We're also going to define a path transition. So we're going to define a path that node can travel across, that we can animate it across. So we're going to define that using lines. So we need line twos, where we can go from a start to end destination. So that's another type of shape. We also have a move to. So we have a line to and a move to, which is a shape. And finally, we have a path, which is a shape. So all of these we'll be able to use to define a path transition. We also have to import our stage, which is our window. That's what everything goes into, so we can actually make it visible. And from JavaFX util, we'll also import our duration, so we can actually create a timing between our animation frames. Okay, so let's go ahead and stub out our basic class. Here, we're going to create a class called Convenience Methods Example. It's going to extend our application class. Here, we're going to have our main method, and it's going to call the JavaFX launch method. Here, we're going to have our start method where we actually have to implement it. Right now, initially, our implementation is going to be empty, but as we walk through the code, we're going to see how we populate that. Then we're going to have all of our private helper methods that will eventually be invoked within the start method. Notice here, I'm opting not to have a class that is stateful, right? I don't want instance variables. I actually prefer to do everything using local variables. And then as methods need data or give back data, I use the return types or the parameter list, right? You try, and the idea here is that you always try to keep your variables as locally scoped as possible. So I showed you two different approaches, but this is the approach I personally prefer to use. Excuse me. So here, I'm going to have a helper method that's going to set up a circle. It's going to return back a circle. I'm going to have the helper method that's going to set up a path. It's going to return back a path. I'm going to have a helper method that's going to set up a path transition. And the path transition is going to happen on my circle. And it's going to transition on this path. So it's going to require those parameters. And so then it's going to give back to me this path transition object. Here, I also have a setup button where I can pass it some piece of text and an XY position, and it's going to create a button object for me with that text and with that position. I'm going to have a setup circle handler where I pass in a circle and it's going to bind some callback function to it. I'm going to create a setup play button handler where I can pass it some button, play button, obviously. And then I'm also going to pass it the animation object so I can trigger the animation object in the callback function. I'm going to set up the stop button handler where I can pass it some other button, my stop button. And then I'm also going to pass it a reference to my path transition animation so I can tell that animation to stop. And then finally, on my scene for setup scene, instead of explicitly listing the set of nodes I want, the set of elements like the circle and the path and the button that I want to add to it, I could use a variable length argument, right? Parameter list, where I put the data type of the most abstract level, which is node. And when I do ... I can now do a comma separated list of any number of nodes that I can then pass into the scene. And then I'm going to add all those nodes into the scene and then return back a scene instance. Okay, so now that we kind of see what the stubbed out implementation is, and stub means we've declared a method, but we gave the method definition, it's empty. It's just an empty set of curly braces. Let's implement it a helper function at a time. So the first thing I'm going to do is set up a circle. So I'm going to make a circle. I'm going to set its XY coordinate. I'm going to set a radius. I'm going to give it a fill color of brown. And I'm going to give it a stroke width of 20 pixels. And then I'm going to return that circle. So now I'm going to update my start method. So I'm going to create a local variable circle, and I'm going to assign it the value of the circle that I get from setup circle method. Then I'm going to implement my setup circle handler. That takes in a circle, and on the circle, I'm going to use that convenience method of set on mouse clicked. And now I'm just going to pass it that Lambda expression. So for an event as a parameter, I'm going to use the arrow operator to then attach that to this code block where I'm going to display hello world and set the fill color to dark blue. So it's the same effectively event handler that we saw in the other example. So then in my start method, I'm going to update that by just invoking the setup circle handler and passing a reference of circle there. Then I'm going to go ahead and define my setup path method. So I'm going to create a new path. I'm going to set a move to position. So this is a start point, an X and Y start point. So this is the starting position. Then we're going to create our first line. So we're going to create a new line 2 instance. And that's going to be an XY position. And then we'll make another line and another line and another line and another line. So it's going to be 5 different lines that we're going to move across. Then inside of my path, I'm going to get my starting position. And then I'm going to add to my path these lines which are these additional points. So it's aligned to, so I have a starting position, then aligned to this, then aligned to that, then aligned to this, then aligned to that, then aligned to that, and then aligned to that. And then after I add all of these lines into my path, remember, I can invoke the get elements to get the list, and then on the collection, I can just add the add, and then I can add any number of these nodes into it. Then I'm just going to return that path. And so my start method is going to be updated. We're going to create a local variable path, and then I'm going to assign it from that callback function, setup path. Then I'm going to define my setup path transition that takes in the circle and path. And here I'm going to create a new path transition object. Then on my path transition, I'm going to set the duration to be every second between frames. And so that's going to be or the duration of my animation is going to be a second. And so I'm going to set that by milliseconds. Then I'm going to go ahead and set my node. Attach the node for this animation is going to be the circle, the thing I pass in. And then the path of this path transition is going to be the path that I've defined that I pass in as this parameter. Then I'm going to set the orientation to be orthogonal to tangent. So that's the orientation of the path. Then I'm going to set the frame rate. So set the cycle count to be 50 milliseconds. And then I have the option to auto reverse. So to play the animation backwards, we're going to do false. And then we're going to return back that animation. So here I'm going to create a local variable inside my start method. I'm going to update that to have a local variable path transition. And I'm going to bind that from my helper function, setup transition. And then I'm going to go ahead and define a setup button where I can pass in that text and that XY position. Here I'll create a new button element using the text that got passed in. Then I'll set up the layout X and Y out, layout Y, that's the position, then return back that button. And actually just call this not play button, but more precisely just should be more generic here. There we go. So now inside of my start method, I'm going to create two variables. One's my play button. So I'm going to set up button where it says play, and then one set of XY positions. And then I'm going to call that same method to create a stop button in my start method that has the text stop, and then another set of XY positions. Then I'm going to set up the play button handler. So that takes a button instance and takes a path transition. And all I'm going to do is on the play button, call that convenience method, set on mouse clicked, and I'm going to pass it just the event, a Lambda expression that is my event handler. So here I'm going to display hello world, and I'm going to tell the path transition to play that animation. And then I'm also going to define the setup stop button handler where I go ahead and take the stop button that gets passed in, and I'm going to use the convenience method to set on mouse clicked there to pass a Lambda expression that defines my event handler, where we tell that path transition to stop. Then finally, I'm going to do my setup scene where I'm using that arguable variable length of nodes. Here, I'm going to be able to just pass all of my nodes. I can pass an array of nodes into this container class and then get back from it a root node, my group, my container. Then I'll pass this root node and the width and height of my scene into the scene constructor. I'll set a background color to my scene, set fill, make it lavender, and then I will return back the scene. So now my start method will go ahead and have a local variable of scene, and it will go ahead and give it the value that's returned back from the set scene method. And then finally, I'm just going to give my window, my stage, a title. I'm going to give my stage, I'm going to set the scene of my stage with the scene that we've created, and then I'm going to tell it to show, so everything becomes visible. So at this point, I should be able to go ahead and compile and execute this code. Let's try it out in real time so we can actually see what this looks like since we're using animations. So let me move over to my IntelliJ. And here I'm going to double click on here. This is the code that we had just examined. Let me go to the bottom where I have my main method. I'm going to click for my main method to run. We will wait for Gradle to build this out. Might just take just a moment or two. Okay, I see that it's built, and here we go. We now have our window, our scene here, and inside of our stage. And so here, if I click on my circle, I have that event listener that turns it blue. If I click play, we can see, oh, that's my animation that is now moving it across that path transition. And when I hit stop, press stop, it will stop it from that animation, and then I can play it again and I can stop. And each time I interact with anything, it's telling hello world inside of the console. Excellent. So that's just an example of how we can also set our how we can do our event handling using those convenience methods. Okay, let's go back. The last thing I kind of just want to cover when we're talking about event handling, it's going to be the specific event types. I think it's important that you just understand what are all the event types that you can map your event handlers to. And so there's fundamentally a couple different types, right? You have the operating system generated events, and those are all the input types. So those are probably going to be most of the events that you use. So those are things like the mouse event or your key event are really, those happen above the level of our application, right? Gesture events, and they're passed our application by the operating system. So the JavaFX background processes uses the information to identify the right node to enact the event on. So some quick highlights you should know. You have key events, which are coming from the keyboard. There are only 3 key events. They have a key pressed. So that event triggers when you press down on a key. You have key released. So that event is fired when you lift off of a key. And then you have key typed. And that's only generated when a character generating key is pressed and released. So when you press down and release. And so that invokes a get character method, which will return the letter that was typed. And that is included as part of the event. Yep, these are, and so again, the key events also have those set on those convenient methods. Then you also have the mouse events. There's many more mouse events. They have a mouse pressed, mouse released, mouse clicked. They have mouse entered target, mouse entered. So like moving into the boundaries of a node, mouse exited target, mouse exited, mouse moved, mouse dragged, and drag detected. So those are all 10 different events that a mouse, that the mouse input or the event could actually trigger. They have touch events. There's only 4 touch events: touch press, touch move, touch release, and touch stationary. They have gesture events that break. There's 13 total gesture events, but they break into 4 different categories: rotate events, scroll events, swipe events, and zoom events. And then besides the system related events, which are all of our input events, there are some JavaFX originated events. So the JavaFX has the ability to create and dispatch its own events. There are 3 types of events that JavaFX can create internally within the app. They're called action events, they're called worker events, and they're like edit, modification, sorting events. So the action events is designed to span multiple input types, defining a single piece of executable code to use in the case of a specific user action. So controls such as a text field and buttons might have an action event. So the layers functionality over the user interface in a way that can span multiple user inputs. So examples might be like clicking a button or hitting enter when the button is in focus, or hitting enter in a text field, or arming or unarming a toggle button. And so the event type, though, of an action event would actually be action. That's how you would try to register a event handler to that. Then you have worker state events. So if you have a long running task that you might want to outsource to a separate thread, to like a worker thread, so it doesn't block the rest of your application from running, you can actually go ahead and set an event so that when the worker is done running that task, it can then update your graphic interface with that new result. And for that reason, these worker state events can have whether it's ready, whether the task was canceled, whether the background task failed, whether the background task is still running, whether the background task is scheduled, or whether it succeeded. So this is just a way, if you're doing something long like downloading or running like a machine learning algorithm or a heavy computational algorithm, that you don't want to wait for the result, you don't want to get the lag in your graphic user interface, you can outsource to a worker. And then the final one that is going to be a JavaFX originated event is for like editor modification or sorting events. And these events span a number of uses, but they're all responsible for updating complex UI elements that can't be achieved through just property binding. So this is like to be able to do like tree modification events or cell modification or sort events or scroll to events, which I won't spend a whole lot of time on, just letting you know that those exist. So if you ever build out an application and you're doing your event handling, you have a much deeper knowledge of how the event delegation, event handling, and the event types are all defined. So with that said, does anyone have any questions? I feel like we've finally really hit a place where you have a strong enough foundational knowledge of JavaFX to potentially build your own applications. You should know how event handling works now. We've already looked at the basic architecture of a JavaFX application, and we looked in depth of all the different various control components that we have. And we even built a couple of applications that kind of draw shapes. So I think we had fun with it. Okay, so if there's no questions, this is it. This is the last lecture. So if you haven't got in touch with me yet, go ahead and I'll probably try to post whatever the test grades are later today. So check Moodle tomorrow for grades. And I'll also go ahead and get the final posted ASAP. And you'll have all the way until Monday to do the final. And I'll be doing my grading on the final Monday, so I can get the final grades in probably Tuesday morning. Now, if for any reason you need a debug session with me, I am going to end this session so the video can start processing, and then I'm going to relaunch. So you can just join back into the Zoom room after I end this. I have no idea what the lab schedules are, to be honest with you. Yeah, I'm pretty sure today's just the last day of lectures. Everything else is finals.